Am I audible? Can you please confirm? Am I audible? Can you please confirm? Am I audible?
Yes, you are audible.
Okay, thank you.
Could you hear me?
Yeah, yeah, I can hear. Okay, so welcome everyone. So today we are going to start the last week of the tutorial session. That is the week 12 of tutorial session of the course Deep Learning by IIT Ropar. I'm Abhishek Thakur, Prime Minister Research Fellow at IIT Hyderabad. So today we'll discuss some of the basics, concepts and questions based on the week 12 lecture that was uploaded on NPTEL portal. And also this video will be uploaded on YouTube. So if you have any doubt, you can ask later on YouTube comment also, and you can watch the lecture later onwards. So before moving, just we'll see like in this tutorial session, that is the week 12. That is basically it is discussed on encoder, decoder, and then attention mechanism and these kind of things, like how we can use RNN after CNN. So these kind of things, when you see all the lectures of week 12, you will get to know, and we'll solve some of the questions. So but before that, we'll see like the problem of language modeling, what we have already studied in the previous lecture. So in this, so what happens like uh, we are already given the word at t minus 1 time stamp, and we have to predict the word at tth time stamp. So so word up to t minus 1 time stamp is will be like it will be given as an input, and we have to predict the word at the tth time stamp. So basically our prediction will be like this: output at tth time stamp such that y1 comma y2 up to yt minus 1 is given. Okay, so this is our main task in this language modeling. So here you can see in this diagram that it starts with the first word, and after that here s naught is initialized with some random value now, and later on we'll see the use of s naught. And in the next term, like this is given as the output, that is s1. This is given as the input to the next block, and accordingly the next word is predicted. So here you can see the word whatever is predicted, that is a probability distribution, and uh, the maximum probability among all the words will be taken as the output, as you can see in this diagram. So it is simply the word that we predicted at the previous time stamp, and so here this is like this, suppose this is our jth word. So this will be having the maximum probability, and this will be predicted, and this will be again given to the input to the next block, and again this will predict again the output will be predicted, and it will be given to the input to the next time. So in this way, like the previous outputs are behaving as an input to the next time stamps, and we predict the word. That is also the language modeling task. So we'll move on to the first question based on this auto completion. So given the first five words of a sentence, our, yeah, any doubt?
Yeah, I'm discussing the problem. Do you have any questions on that?
Okay. Okay. So given the first five words of a sentence, our model has to predict the next word for an auto-completion task. Which of the following is the output at every next time step? So our output will be the probability distribution over the vocabulary, and in this, whatever will be the maximum probability value, that word can be taken as the output. So this is just a simple question what we have discussed before, and we have
So,
two three more
sir,
questions following to this.
sir, here, which means if there are some five words, among whichever the word is having the maximum probability. So across over the distribution, which is having the highest probability, will be fed as, given as the output. Am I correct?
Yeah, yeah. Like let's
Okay.
suppose there are five words. So here is I am world. Let's suppose any word, this XYZ. So let's suppose this is am have a probability of 0.4, this is 0.2, this is 0.1, and this is 0.1. So total probability distribution sum will be 1. No, 4, 6, let's suppose 0.3. So this 0.4 will be the predicted output because it is having the highest probability among all the words given in the vocabulary. So we'll move on to the question number 2. That is also the follow-up of the previous concept. Consider the language modeling problem. Before that, let me check whether the video is recording. Yeah, it's recording. Consider the language modeling problem in the question 1. How does the RNN take into account that a word at a TH timestamp depends on the few words preceding it? So in this, we have already discussed that the previous output is given as input at every timestamp. So the option C is correct for this option. As we can see, this previous output, that whatever is predicted here, that is given as the input to the next timestamp. So this is the answer for this language, this question number 2. Like at the word at the tier timestamp depends on the few words preceding it because the previous output is given as the input at the every timestamp. Now we'll move on to the question 3. Identify the reason for using softmax for the RNN modeling uh, given below for the language modeling problem in question 1. So we are using softmax function for this language modeling problem just because we know that when the probability distribution is given, when the output is a probability distribution, like sum of all the classes of the output is equal to 1, then we use softmax. And the loss function used the cross entropy loss function. So this we have already studied in the previous week. So now we'll move on to the question number 4. What is the size of the vector? Just wait. What is the size of the vector probability of word at t timestamp, and given that the previous words at the t minus 1 timestamp? This is just the language modeling problem what we have discussed before. So what is the size of this vector? It is asking. So this is generally the size is the number of word in the vocabulary because whatever in the probability distribution, it is just giving the probability of all the words in the vocabulary. So the size of this given vector, that will be equal to the number of words in the vocabulary. That is option C is the correct for this question. Like this is asking what is the size of the vector this. So like this is the probability distribution of the output function. So the size of this probability distribution is the number of words in the vocabulary. Because how many number of words will be there? Let's suppose there is n number of words. So it will give the probability of all the words. So this function will give this probability of all the n words. So the correct option will be number of words in the vocabulary. So we'll move on to the next question. This is just a question based on the previous thing. That is, which of the following activation functions can lead to vanishing gradients? So we know that tan h will lead to the vanishing gradient because the curve, the derivative of the tan h will become 0 in the positive side also after some part, and in the negative side also after some part. So what happens when generally, like when the gradient becomes 0, then the change in the like next time step will be very low, and this will lead to the vanishing gradient problem. In ReLU, it will not happen. In the negative part, the gradient is 0, but in the positive part, the gradient will changes linearly. So the correct option for this is tan h. We'll move on to the question number 6 now. This was very simple question, I guess. So now coming to the question, question number 6. Consider the problem of image captioning, like captioning a image. So image will be given, we have to caption it. Here this is implemented by feeding an abstract representation of the image with CNN as a fully connected layer of 7 size, like 0 to 7, that is 8 size. What are the different ways of doing this? So like there are two options. One, that we feed this S naught here, like the the final layer of like when we do the image classification thing, the final layer is a fully connected layer. After all the convolutional layer, we get the fully connected layer, that is a flattened layer, and each neuron is related to the previous neuron. So this fully connected layer, we are giving input to this RNN, and now according to this image, this S naught is given, and this will like help us to find the how to caption it. So this is just the basic things. So this is one option, and the option two is like we can give this fully connected layer at the each as the input of each ST. So here you can see it is given like this. So it is given as input at each time stamp, and after that this is option 2 for this image captioning problem. So here this is asking what are the different ways of doing this. So either we can set S naught is equal to FC7I, or also we can feed this as an input to ST at every time step. So both way we can do. So the option C is correct for this image captioning problem. So this thing you can study in lecture also. This is a tutorial session, so we are discussing the normal basics questions. Now moving on to the question 7, that is based on RNN. So which of the following application is the odd one? It's not based on RNN. It is like based on the whatever we have studied. Uh, this kind of network that is based on the we can use CNN also over RNN in case of image captioning and video captioning, and mostly for sequential learning problem for predicting the next word or sentence. We use sequential learning network also. So in this, like, it is asking which of the following application is the odd one. This means the other application will be of similar type, and which is the odd one application.
Image classification.
Yeah, image classification, because all these are just the predicting of text, and image classification is the prediction of the image, which kind of image it is. So this is image question answering, that is the based on image some question and answer will be there. This is translation, and this is the document summarization. So given on the document, we have to summarize for what this document is, and we can give a small summary. And video captioning is also the we can do in a similar way, but image classification, that is only can be done using CNN.
What is trans?
Like translating of
Language of-
yeah, something like that. Even in like same language also, or even in different language also, like some French to English or something like
Oh,
that. So now moving on to the, yeah, I have kept here question number 8, that propose an encoder-decoder architecture for the task of image question answering. Given that the input is combination of an image and a question, the expected output is an answer. So in this, what is given, that the input is a combination of image and a question. So we have to, and the expected output is the answer. So this is just the image question answering problem. So which architecture we will use? So this can be easily done using the concatenation of CNN and RNN for the encoder and feed forward network, as we have already studied in the week 12 lecture. So if you go through the lecture, you will know how it can be done. So it is just the combination of both. Like also we have seen here that how we can provide the final layer, that is fully connected layer of CNN to this network. Now we'll move on to the question number 9, that is identify the most suitable encoder for the task of video captioning. So the for video captioning task, the RNN of CNN is used. Like first we'll use CNN, then we will use the RNN of that. So here you can see this slide is taken from the class lecture only. So this is a video captioning task. Here input is video, and output is we have to describe the video. That is the captioning of the video. So here you can see first the CNN used on this video, like the each frame of the video, that is also known as image. So we have used the CNN on that, and after that the RNN is used like this. You can see this output of this is provided to the RNN network, and after that the captioning is done, that a man is walking on a rope. So for this kind of video captioning, we use RNN of CNN. CNN is just used to first get the output from the images. That is the final layer we use as the fully connected layer, and that we gives as an input to the RNN to describe or captioning part of the video or images. So now we'll move on to the question number 10. That is, suppose we know that only one word seen so far is important, then it is sufficient to feed only that important word as input to that timestamp. But in case we know that three or more words are important, how this can be handled? So like if we know that one word is important, then we give directly one that word as a input to the next timestamp. Okay. But if there is like three words, like let's suppose these are the first three words, and this is the fourth word. So we have to predict the fourth word, and fourth word depends on the first three word. Like we cannot predict the fourth word using third word alone or any word. So in that case, how we can give the output? We get give the weighted sum of the important inputs. Like if let's suppose these three are the important inputs, so we can give the weighted sum. Let's suppose second input is highly valuable, so we can give a weighted sum like 0.4, 0.3, or 0.2. This will be the value of alpha. So this is also known as the attention mechanism. So in this, the option B is correct. That is weighted sum of the important inputs. So now we'll move on to the question 11. That is chatbot application. Consider a chatbot application where the input is a series of sentences of indefinite length by customer, and output is the response of the application. So this kind of chatbot application is solved using the hierarchical RNN. So these are today's this week lectures were totally theoretical only. So questions are also based on the theoretical of this week 12. So today we will having this simple question, and this video will be also uploaded on YouTube. If you have any doubt, then you can ask it now, or even you can ask it later on the YouTube comment box.
What do you mean by hierarchy?
Like there will be one another RNN that will be above of all the layers. Like there will be two level of RNN encoder. The first level RNN operates on the sequence of the word, and after that there will be one more layer of one more level of RNN above.
Okay. Okay, sir. Then, the difference between document classification and summarization. Classification. We are saying whether the given
Huh.
letter is A or E. Like,
Yeah, it's belong it that is like it belongs to which class class like even this letter is belonging to political document or sports document like that. And summarization is like a few lines about that document.
so we will go for RNN only for summarization, not for classification. Am I correct?
We can go for classification also. We can use RNN in this because after summarization we can easily know that which class this document will belong to. Like if we get some somebody like this is a political document, so we can do using that because this is basically predicting through the words only.
No, for classification, we will go. We will be comfortable with the feed forward with the softmax.
Yeah, we can use that, but the RNN layer will be used because this is the also a language modeling problem only because we have to take each words in the document to classify.
Here,
Like like see don't like if you see the image classification that is different. That is like you have to divide the each images into different parts and do the convolution and those kind of things. Here we have to take again each words in the document and then we have to classify the document belongs to which like which class. That is similar to document summarization also. Like even in that also you can summarize this is a political document like that. Okay.
which should be used from decoder. I feel document classification, we can go with the feed forward with.
Yeah, we can go, but document summarization will be the more appropriate answer here. If this two is the given.
Both are given for classification and
So
the
is
document.
it a single choice question or the multiple choice question?
It's a single choice question.
Then document some summarization will be the I guess appropriate answer.
No. What should be the decoder used for following? Number one is document classification. Number two is document summarization.
Hmm.
And the multiple answers are given. One RNN, two feed forward. One feed forward with the softmax, two RNN like that. So I feel feed forward with the softmax will be more apt for classification
Hmm.
and RNN for summarization. Is this correct or?
Yeah, RNN for summarization will be correct.
Okay, feed forward with the softmax because the softmax takes the probability.
Yeah, yeah, it will. It yeah, that is for classification. Softmax will be appropriate because it
Okay.
will deal with the probability and we can classify with the
It's a little bit ambiguity here. That's why I asked.
yeah.
Okay.
Okay, then today we will close the lecture here, and this video will be uploaded, so you can also watch on YouTube.
Thank you.
Thank you so much for attending the class. Thank you.